Deepblocks is a Singularity University company, and it is optimizing the way we look at cities for real estate development. So right now with what we've built, we've been building for 5 years, we can scan an entire city in minutes and find where there are opportunities for development. So in this presentation, I'm going to take you through a little bit of the general kind of logic that we looked at, how we applied that to creating Deepblocks, my experience there, and show you what we've built. So we looked at kind of a general sense at Singularity University of how things were working. And we noticed that there's a lot of fragmentation, right? There are nations, and we have states and counties and cities and neighborhoods and races and classes and genders. And every single one has resources and information that are unique to them and that become really important. And in a way, we think of these things as finite. So then we spend a lot of time, in a very abstract, general sense, trying to bring more of these resources, and because they're finite or perceived as finite, then we bring them from our neighbors or from other fragments of the world and society at every scale in some way. And to do that, sometimes we even sacrifice some of these resources for the sake of getting more and holding on to more. These are misused resources. So what if instead we thought of ourselves as one, instead of a bunch of fragments, as one in some level, in some way, and all of our resources and information was centralized in one place where everyone can use them to produce new things. And instead of the competition being about what can I get from you, it would be what can I produce and how can I then be part of a world of abundance. And this is some of the things we learned at Singularity University. So what does this have to do with real estate? So I'm going to give you a little bit of a journey that I had in my academic studies in real estate development. So I started at a University of Florida, a bachelor's in architecture, 4-year degree, and then I did a 3-year master's at Columbia University, also in architecture. And I'm not sure if I wasn't paying attention, but it took me 7 years to realize that the architect did not actually make the buildings or the decisions to make the building. And that the real estate developer had this power, and by the way, they did not require a degree. So I just spent 7 years, and I wasn't close to doing what I wanted to do. So I did a second master's in real estate development to understand what was this other part. And what I learned was that the industry was even more fragmented, and there were so many other parts. And I was really discouraged, because I had now spent a lot of money in education. And I wasn't able to do my building. So real estate development is fragmented into many disciplines. The developer, the lender, the broker, the architect, the contractor, the engineer, the land use attorneys, the city, it goes on and on and on. And each one has a different language, different resources, different information, all of which are needed to create this building that I just wanted to create on my own. So I was already heavily invested, so I went and I worked for contractors, for developers, for architects, for brokers, and I was like, I don't care what I have to do, I'm going to have all of this information myself. And what I learned was that they don't even like each other. And this whole time that they're collaborating, they're all trying to get the highest fee from the project for the least amount of work. And because there's so much tension between them, then that becomes the goal. And the goal is no longer what can we produce and how can we innovate, but the competition is misaligned. How much can we get from this project? And it's so much so that between 30 and 40% of a project's total cost, the equivalent of that is what the fees are. So the end user is the one that pays for that. And the products that we produce in general are suboptimal. So I left the industry. I said, I'm going to cut my losses. I'm not dealing with this. I am completely uninspired. And there's no way for me to do all of this myself. So I got into a program with the Department of Defense, the DARPA Innovation House. And the only reason I got in is because they were really confused by my application. And they said, what the hell? Let's see what you have to say. So I used everything I learned in architecture, and I designed, it was a program around big data. And I designed a big data navigation software that was three-dimensional, haptic, VR, and would go from, at the time, analysts looking at one picture at a time to looking at thousands, tens of thousands of pictures, and being able to find patterns using multiple senses. And I thought this was my calling. So then I went to Singularity University to take this DARPA project with me and develop it further into something where I imagine bringing information directly into the brain. I had absolutely no experience in anything in biology or anything in AI, and I had just spent a couple of months designing this software that got first place in innovation, so it gave me kind of a confidence about it. So at Singularity, we had to pitch, kind of like I am now on stage, to see if we can recruit members to join your startup. And that was kind of part of the first phase. And there was this young man, Bernard, who was speaking really passionately about lowering the cost of living by lowering the cost of housing. And nobody was joining his team, and nobody was joining my team because I had zero experience in what I was talking about. So then I said, well, I might as well share what I know, my X amount of years in academia. Let me at least explain it to him so that he doesn't, maybe he makes the choice not to even go down that path because it's all messed up. So I wrote this giant whiteboard on how the whole thing works, how it's connected, what are the attitudes, where do they meet, where do they transact information. And he looked at it and he said, this can be done by an AI. And his background was in machine learning. And at that moment, something happened. And this dream and this pain and this fury that I had for the industry totally changed. Because now it was possible, at least in our minds, to create this centralized place where all the logic, all the insight, all the calculations lived so that each one of these players can have the information of the rest and create a building on their own. And then you can imagine the architect would create a building that maybe wasn't as profitable, but maybe it was a really great experience. And then the developer would create a very efficient and good return building, and the engineer would go far and beyond. And each person having the information of the rest can create a different type of competition, a competition of product, and a competition of bringing innovation into the market. So that's what we set out to do. We raised a round of funding. We spoke to 100 investors before we got our first yes. Nobody thought this was possible, but we got our first million and started building. Today, we have 80 paying customers. We've been onboarding customers along the way. And one of our customers said something really nice, that we were the most useful sourcing technology in the New York market. So I'm going to give you a little bit of a tour on what the software looks like today, and then I'm going to show you some videos on it actually working. So the first thing we did was follow the path of development. And we baked in to every single parcel of the city all of its rules and regulations and all of the market data. So then the first thing we had was this giant query that we can say, okay, in Miami, where can we build 200 square foot of industrial, and there's currently less than 5,000 square feet. Now there's that big development delta. And out of 10,000 parcels in the viewport, we have a list of 30 that matches this search. To give you an idea, this would take at least 6 to 8 months of what we call canvassing a market. Because municipalities, the rules for zoning are in a PDF that are not attached to a parcel, and definitely not attached to a parcel that has information about that market or parcel. So all of that needs to happen manually through the collaboration of these disciplines that don't really like each other. So the first thing we did was allow our customers to scan across 100 cities and look for these opportunities much faster and find a lot more efficiency. All of these data sets we've also visualized because we want to see what patterns these professionals use intuitively, so that then we can create algorithms that get them to that point much faster. So we're now opening a marketplace to bring a lot of data providers that are not really being seen by large corporations so that these local data sets can be really helpful in finding opportunities, demand, and so on. Once you select the site, it builds an automatic 3D model and financial model so that this time of going back and forth with architects and contractors, that goes away in the preliminary phase. And now you're able to see the viability of the investment in a matter of minutes. So now you have a short list, and you run that short list through the modeler, and then you're able to see, is this something I want to pursue or not? Again, this would take months otherwise. And this has a really interesting future of being able to automate these rules and optimize these models. We're not there yet, but that's where we're heading, so that we can say, these are the 5 perfect, highest and best use for this community for these reasons. So one of the hardest zoning data sets is zoning data. We're actually the largest holder of zoning data in the country, of digitized zoning data, because nobody was digitizing this data, and we had to go zoning code by zoning code, extract the right value so that we can use it as an automatic rule base for generating these models and querying the cities. So 80% of our operation is about digitizing these data sets. It took us 3 years to do 40 cities manually and understand how these cities work, what they had in common, and then 6 months to do the next 60 cities using a series of very simple machine learning models to help us identify where the information is and help us compare to see if information had changed in order to update the zoning code. We hope to be in 750 cities in the next couple of years. But also, we've been able to normalize a lot of this data so we can compare across cities. And that's really difficult. Cities don't communicate. Cities don't even know what their total buildable area is because they have no way of understanding what their rules produce on each individual parcel and as a collective. So we're now able to say Tallahassee has 3 times as much total buildable capacity as Gainesville. But funny enough, on the industrial side, Gainesville has 4 times the capacity as Tallahassee. So we're able to do this across the 100 cities and provide really interesting insights. We're also able to predict construction activity to see what cities might have an increase in construction, which would be an interesting place to develop and purchase land early. And we're also breaking it down by census tracts so that we can say, okay, this census tract has a high construction activity in the last 10 years, an increase in population, or one of the highest trends in population, yet a low land value. That's a huge opportunity to go in there and invest immediately. And so bringing this together, we're able to rank opportunities across these cities and look at the entire country, and at this moment 100 cities, and select where we should buy when and what should be built at a very kind of efficient way so that anyone can invest and eventually anyone can build. So right now we have built this robust software. We've used machine learning to extract zoning data. We're now trying to predict the next boom markets and where one should buy real estate. We're opening it up next so that we bring all these data sets. We also want to bring functionality, services, and even do transactions and kind of see what happens in the blockchain space to facilitate for smart contracts and transactions in the software. And we want to get that 3D model with all those rules to get really smart to the point where we can feed it kind of to do like biomimicry algorithms to understand in this city, should buildings be more like mangroves? And in this city, should building be more like oaks? And how do we take models from nature and have the buildings behave like the natural ecosystems and have them produce resources and definitely not produce waste? And how do we begin to embed really interesting models into this work? So in summary, we've taken a process that requires a lot of different players that they're smiling right there, but you could tell is a little bit fake. And in each individual of these players have a really tough time understanding everybody else and getting the data of everybody else to make really important decisions, like where are people going to live and what is that going to look like? And we've turned that into a video game-like experience where all the data, all the calculations are coming in together. I'm not saying we have all of it already, but we have enough to save months of work in site selection and weeks of work in these conversations with architects. So this is a case study that we're using the actual software. We're looking at New York. We're seeing where there are pockets of opportunity, pockets of density. You see those in red. And then out of those 10,000 parcels, where can I build a very specific type of building? Then we can zoom in into one of those clusters and very quickly explore the area. We get the rules for every single one. We notice one of them already is under construction, so we were too late. And we can very quickly, without going there, understand what's available and what's possible. And then you can model this and see what is the right combination of uses, the right combination of units, what would be the most profitable. And eventually, we can do this for our customers and suggest these solutions. So we want to be able to scan the city and find where the needs are and what should be built, and then open the door for opportunities for affordability, for new methods of construction, for new methods of sustainability, and be able to model them at no extra cost for free, understand what the potential is for these technologies that are not being used today. And at a much larger scale, at the scale of a city, the city of Miami is now a customer, their planning department. And believe it or not, planning departments don't have financial analysts. So when they make decisions on zoning, they don't know what the financial repercussions are. So they don't know if it's going to be profitable to invest and buy land there or not. And that's why you have so many zoning changes all the time, because developers are constantly speaking with the city saying, unless you change this, there's no way we could build here. So now cities can look at the financial consequences of what they're doing and learn from other cities, which is kind of becoming, these fragments are kind of becoming together, at least in the world of real estate, so that we can optimize for society as a whole. So we're Deepblocks and we're optimizing cities. Thank you so much for your time, and thank you for having me.